Hello everyone, my name is Nisha and I am an application developer in Fujitsu. My work mainly involves contributing to open source Postgres, mainly in logical replication. So today I will be talking about a new feature introduced in PostgreSQL-17, which is failover logical slots to ensure high availability of logical replication when failover happens. So this talk's agenda is we will start with some logical replication overview and how logical replications play an important role in doing the replication, and then we will define the problem statement, what happens to logical replication when failover happens, and then we will see how it happens in Postgres 16 where this feature is not available. Then I will introduce to the feature of synchronizing the logical slots on standby, how to configure it and what are the methods of synchronization, manual as well as the automatic. Then we will see how this new feature can help reducing the downtime of logical replicas in PG17. Then next I will go over briefly few steps we can use to ensure like your standby replica is ready for failover if it has any failover slots. So let's start with logical replication in Postgres. So in database, replication means copying or maintaining data of one node to the other node. So the node with original data we call it as upstream node, and the node where we are copying the data, we are maintaining the copy of the data, we call it as downstream node. So Postgres supports two types of replication. One is physical replication and other is logical replication. So physical replication, which is also known as streaming replication, it replicates the changes from upstream node to downstream node in raw data blocks. That means the standby node keeps the exact same copy of data of the upstream node, whereas in logical replication the changes are replicated at logical level and it works on publish subscribe model. That means the upstream node sets the what all changes is will be replicated, and downstream node subscribes to those published changes. So that's why we call the upstream node as publisher in logical replication, and downstream node we call it as subscriber node. So how one main difference between physical replication and logical replication is that logical replication also uses wall to see the changes and send it to subscriber, but to do that it uses a concept of wall decoding, also known as logical decoding. So by using logical decoding, it can find out what actual data is relevant and what actual data a subscriber needs, and it can send it to our. So I will not go deep in logical decoding because that itself is a big topic. But here you can see an example of a typical logical replication setup where upstream is publisher and it is publishing all the changes for T1 table, and downstream node is subscribed to all the changes for T1 table. Now let's see writes are happening on the publisher node on T1 table, T2 table, T3, many writes can happen on any table, but publisher node can filter out the changes which subscriber needs, that is T1. So insert happened on T1, we will decode, like at publisher node it will be decoded and then it will be sent to the subscriber node. After receiving the same change, subscriber can apply the same insert on the T1 table, and that's how they keep replicating the changes between these two nodes. So next let's see what are replication slots and what are their role into the logical replication. So depending on the replication type, we also have two types of slots. One is physical slot, which is used in physical replication, and other is logical slot, which is used for logical replication. So slots are mainly there to ensure that upstream node does not remove wall, which can be still required by the downstream node. So in case of logical replication, it also has an output plugin which is used by the logical decoding, because output plugin will only decide like what data to transfer to subscriber node and what data to ignore if it is not subscribed. So in this example, it's a little bit zoom in operation which happens on the publisher node when logical replication is happening. So as the writes are happening on the node, publisher will keep updating the wall, and a background worker called wall sender, it will keep decoding all the changes and it will keep that in reorder buffer. So as soon as it will see that there is a transaction is committed, it will send all the data related to that transaction to the output plugin, and then output plugin will see, okay, T1 data is required by subscriber, so it will transfer it to subscriber node, and if some data is not required, then it will ignore that data. So that's, you can say, like in a way replication slot is the way to replicate the changes. It holds all the information required for replication. So we will see an actual example of slot and what all information it holds. So you can see here I created an logical slot using the SQL function PGCreate logical replication slot. So I specified the slot name as logical slot, and I also specified the plugin test decoding. We also have another output plugin, PG output, if you have heard of it. So as soon as I create this slot, now if I want to view what all information this slot holds, I can query the view PG replication slot. So here I haven't displayed all the columns because it's a big view, but this much will give you an idea what all information a slot holds. So you can see the slot name is logical slot which I specified, and plugin is the output plugin. So I created the slot with test decoding plugin. So this is the plugin for the slot, and again the type of slot is logical, and if you create a physical slot, you will see this type as a physical. And because I created on Postgres database, the database is Postgres, and right now this slot is inactive because nobody is using this slot for any kind of purpose like replication or anything. So this active column is false. So if anybody starts to use this slot, you will see this active as true, and the respective process PID will be shown in active PID column. Similarly, this xmin column is there to tell that this slot requires this transaction ID. So don't remove rows for till that transaction. Also restart LSN is the wall location, oldest wall location which is required by this slot. So if you can see wall status is also reserved, that means if this slot has restart LSN at some location, the wall beyond that location will not be removed. Okay, and we also have confirmed flush LSN. This is the wall position which subscriber tells the publisher that I have flushed all the changes till this location. So this is a confirmation location. Also there are other properties also like invalidation reason. So if it is non-null, that means the slot is invalidated with the given reason. So this is how slot looks like, and we need slot for logical replication. So now we have a fair idea of logical replication and how the slots are important part of logical replication. Let's define the problem here. So what is failover or switchover? So failover is the process of automatically switching to the standby server when primary server fails. Switchover, same thing, but it is a planned and manual process of doing the same thing. So whenever a failover happens or switchover happens, to ensure the high availability, we want to make sure that standby node becomes primary node as soon as possible, and the time taken in this process is called the downtime. So our goal here is we need to minimize this downtime whenever failover happens. So let's see how logical replication is impacted during a switchover in PostgreSQL-17 where this new feature is not available. So, consider a setup where I have 3 nodes. Node 1 is the primary or publisher node, node 2 is the standby node of the node 1, and there is a logical replication setup between node 1 and node 3. So, node 3 is our subscriber node. So, as part of switchover, first step would be to stop the primary node. So, as soon as primary goes down, the replication breaks, and now there is no longer logical replication happening between node 1 and node 3. So, the second step would be to promote the standby node as the new primary node. So, now node 2 is the new primary, but logical replication won't start as soon as it becomes primary, because mainly of 2 reasons. One, subscriber has no idea who is the new primary node, and standby also does not know like if it has to start logical replication, where to start it and how to start it. So, to do that, we have to follow some steps on the subscriber node. So, first is to disable all the subscription, then truncate all the tables which are involved in logical replication, and then recreate the subscription to the node 2, that is the new primary. So, when this recreation of subscription happens, depending on how many tables are involved, how big the tables are, it can take some significant time. Like if the tables are in TBs or petabytes, this step, because it will resync all the initial data of tables from node 2 to subscriber. So, this is a significant time consuming step. So, let us list out what all challenges we just saw in PG16. So, as soon as primary goes down, we lost all the replication slots which were being used by the subscriber node. So, now subscriber can no longer replicate. So, all the services to the subscriber node are down, and to resume its services, subscriber have to recreate the subscriptions from the new primary node, and that will take significant time if the larger data sets are involved. So, it can delay the overall recovery process of the cluster. So, now to overcome these challenges, this new feature was introduced in PG17 called synchronization of logical slots to standby. So, the root problem we saw was that standby nodes do not have the slots which were serving the logical replication to subscriber from primary. So, the solution is sync all those logical slots to standby in real time. So, by doing that, it will eliminate the need of resyncing of the initial data, recreating of subscription, all that can be removed. But at the same time, if we are resuming logical replication from same place after failover, then we need to make sure that standby node is always in sync with subscriber node, otherwise there can be some data loss. So, to avoid that, a new GUC parameter was introduced called synchronized standby slots. It takes list of slot names. So, when you specify all the standby slots which should be synced to the respective subscribers, then primary will make sure that all the changes are flushed on the standby node first, then only it will send them to subscriber. So, by doing that, we are always making sure that whenever failover happens, standby is always in sync with subscriber. There is no data loss or any issue while we will be resuming the logical replication. So, let us see how to configure our slots to use this feature. So, to configure any logical slot for failover, a new option was introduced called failover. So, you can set this property as true, and when by default it is false. So, by default this feature is not enabled for logical slots. So, whenever this is set to true, all the logical slots become eligible for synchronization to the standby node. So, user can choose which logical slots should synchronize and which should not synchronize. So, that that is available. So also because this feature is only for logical slots, this property is always false for physical slots, you cannot change it. And now how to set it to true? So there are two options, either like while creating the slot. So if you are creating the subscription and that subscription is eventually creating the slot, then you can specify this property like with failover equals to true, this option you can set to true, then the slot will be created with failover equals to true. Or if you are using the SQL function PG create logical replication slot, the fifth parameter is failover parameter. So if you set it to true, the slot will be created with failover as true. So we can also modify this failover property if the slot is being used by a subscription. So first we have to disable the subscription, then either set or unset the failover property, and then re-enable the subscription. That also works. So my slots are now configured for the syncing, but at the same time we also need some configurations on the standby node. First, the standby must be using a slot for physical replication. So there is a juicy parameter primary slot name that must be configured on the standby, so that whenever replication starts, the wall sender on primary node will use that particular slot for the physical replication. Second is hot standby feedback must be enabled, because then only primary node will get to know that all the changes are flushed to the standby before sending them to a subscriber node. And third is a valid DB name should be specified in primary coninfo. Why? Because internally when standby connects to primary node, it has to fetch all the logical slots information, and to do that it runs a SQL query internally. So to run a SQL query we need a valid DB name, so that configuration is also required. So in this example you can see that first two configurations can be done in PostgreSQL-17 file, and DB name can be specified in PostgreSQL-AutoConf file. So now my logical slots are ready for failover, my standby node is also configured properly. Now how to actually sync these slots? So this feature provides two types of slot synchronization. We will discuss both one by one. So first is manual synchronization. So to do the manual synchronization, a new function is there, PG sync replication slots. So whenever you will run this function on standby node, it will connect to the primary node, it will fetch all the logical slots which are eligible for syncing. That means failover is set to true for those slots, and it will create them on the standby node. So let us say if I am running this function second or third time, it is possible that there are some already synced slots are there. So at that time it will update all the metadata of synced slot on which it saw on primary, and it will update the same for synced slots. It also takes care of dropping the obsolete slots. That means whenever you are running this function, let us say primary dropped some slots, or primary changed the setting, like for this slot I no longer need failover. So if failover is disabled for any slot, that slot will be dropped on the standby. So one point to note is, when automatic synchronization is on, you cannot run the manual synchronization. So let us see by an example whatever I discussed for the synchronization. Consider a primary and standby setup, and let us say primary had two slots, slot 1 and slot 2, and for both of the slots the failover property was set to true, and let us say I ran that function one time and both of the slots are now synced at standby node. So after some time some changes happened on the primary node. So slot 1 was some metadata got updated, LSN was moved, confirmed LSN was moved, and like that. And but slot 2, the failover was now set to false, and there are two new slots, slot 3 and slot 4. Slot 3 is eligible for sync, but slot 4 is not eligible for sync. So now I want to sync all this new information to the standby. So to do that, I will execute this function on the standby node. It will connect to the primary and it will fetch all the logical slots with failover equals to true. That means in this example, it will fetch slot 1 and slot 3. So as soon as it will receive these two slots, it will see that okay, slot 1 is updated. So it will update the slot 1 metadata here also. Then it will see okay, slot 2 is no longer there. So it will drop this slot. And slot 3 is a new slot, so it will create this as a synced slot. So we call this process as one sync cycle. So in whenever this function is executed, this one sync cycle will happen. Next, let's see the other method, automatic synchronization. So to do the automatic synchronization, a new GUC is available, sync replication slots. So when this GUC is enabled on the standby node, a background slot sync worker will start and it will keep syncing all the eligible slots from the primary at regular interval. So the one cycle we just saw, so it will keep repeating that cycle at some time interval. So minimum gap between two sync cycles is 200 milliseconds. So, and whenever it finds that there are no new updates coming from primary. So primary is pretty much inactive and it's not updating slots as frequently. Then this worker will go to nap, and this nap time is also dynamically tuned. That means every time it finds there are no new updates, it will double its nap time. But max it can go to 30 seconds. So even if there is nothing new happening on the primary with respect to slot updates, still it will keep syncing those slots every 30 seconds. So this is the automatic way of synchronization. So using either method, now the slots are synced on the standby node. So these slots are some special slots on standby node. So they have to adhere some property or some rules applies to these slots. So first, how to differentiate these sync slots from the regular logical slots which can be present on standby node. So there is a new flag introduced in PG replication slot view which is called synced. So in this snapshot, if you see the last two properties, failover and synced. So this snapshot is taken from a standby node where the logical slot is synced. So if this synced is set to true, that means this slot is a synced slot, that is synced from primary, it is not a regular logical replication slot. So these synced slots cannot be dropped by user and cannot be consumed. If any logical decoding attempt is done on these slots, it will result into error. And also if the slot gets invalidated on primary node, then the same will be invalidated on standby node. Also in a case, say the slot is valid on primary node, but it gets invalidated somehow on the standby node, then as soon as we find this situation, that slot will be dropped and it will be recreated in the next sync cycle. Also, if let us say this sync is in progress and it is creating some slots, new slots, and those slots are still temporary and failover happens. So temporary slots cannot be used for logical decoding. So in that case, whenever failover happens and standby will be promoted, these temporary slots will be dropped. So now this was the feature overall. Let's see how it helps in PG-17 to reduce the downtime of logical replica. So same setup, 3 nodes, one is primary and or publisher node. Node 2 is the standby node of node 1, and there is a logical replication between node 1 and node 3. So we will stop the primary, we will lose logical replication, we will promote the node 2 as new primary, and now to resume the logical replication between node 2 and node 3, we have to execute only one simple step, because still subscriber has no idea who is the new primary. So we need to just update the connection information. As soon as we execute the alter subscription command to update the connection information to the new primary node, the logical replication between node 2 and node 3 will start. So, here you saw that there was no need of recreating of subscription and resyncing of data. Data is there. Even if there are big tables involved in subscription, we can resume logical replication from the point where it failed. So, this is how we save the time in PG17 using this feature. So, once this connection information is updated, the standby node will now use those synced slots, because the subscriber will connect to their respective slots which were synced, and standby will use all the metadata information which we synced to resume the logical replication. So, now because standby is the primary, so these synced slots no longer are synced slots, they will behave like regular logical replication slots and no special treatment for them, and the failover property will be true only, because that helps in syncing these now synced slots to further down standby node. So, we will keep it true. The synced flag will also be true, because this flag has no meaning as such on primary node. So, but it gives us additional information that okay, these slots are coming from previous primary. So, for that purpose we kept it as it is when the node is promoted. Also, there can be a rare case that some copy data is going on, some new logical replication was set up and the table sync worker is doing the initial data copy, and then failover happens. So, in such a scenario, this copy data cannot be resumed mid process. So, in that case, the table sync worker will start again after failover and the copy will happen again. At till wherever point it was, it has to restart. So, that is not handled with this. So, that was all about what this feature is and how it helps in reducing the downtime of logical replica during replication. Now, I will briefly go through the steps we can use to verify if your standby node is failover ready. This helps when if you are planning a manual switch over and you have set logical slots for failover, and before you promote your standby node to new primary, you want to make sure that okay, all the slots which I require are there on standby node, so that no issue happens in logical replication resumption when failover happens. So, to do that, first thing first, you have to ensure that the standby node is not lagging from subscriber node. So, it should be in sync with this subscriber. So, to do that, as I told earlier, synchronized standby slot GUC is there. This must be set on the primary node, then only it will make sure that standby node is in sync with subscriber. Next, now you have to identify which all slots I need that are synced, that should be synced on the standby node. So, to do that, you have to run some queries on subscriber node. So, first you can run a query on PG subscription, which will this query. So, the queries I am telling here are well documented on Postgres site. I have mentioned the link at the end, so you can go through it. So, I will not go deeply into the queries. So, to get the logical slots which should be synced on standby, you can run this query on PG subscription. It will give you a list of all those slots which should be synced on standby, and also if there are table sync workers running and if the table sync slots also should be synced on standby node, then to get that you have to run this bit complex query on the each database, because table sync worker work table by table. So, but you can just copy paste this query and change whatever is required as per your setup. So, this will give you the list of table sync slots which must be synced before failover. So, now you have list of all the slots which should be synced on standby before failover happens. Now, you verify on the standby if you have all those slots synced or not. So, to do that, you just have to run a query on PG replication slot with this list you just got in the previous queries. So, as soon as you run queries, make sure you are getting all the slots which are mentioned in this list, and this failover ready is true for all the slots. So, if this is true for all the slots, your standby is good to go, you can promote it to primary and logical replication will resume without any issues. Now, just to list few things which are not supported by this feature. The logical slots cannot be synced to cascade standbys. It is only for the direct standby of primary. Okay. And also this is only for logical replication slots. So, physical replication slots are not supported to sync by this feature. So, to summarize PG-17 logical replication is now more resilient and failover ready. We have a new property called failover for logical slots. When this is set to true, all those slots can be synced to standby node, and whenever failover happens, standby node can use those synced slot to serve the logical replication to the subscribers without any downtime, like the minimum downtime. No table resync is needed in that case. So, yeah, and here I have mentioned all the documents which are which I mentioned and which are related to this feature particular. So, yeah, thank you. This was it. Any questions you want?
Thank you. You have a question?
Why do we need to truncate all the tables when we recreate the subscription?
Because we don't know where to start from the new primary. We don't have that information on the standby node. So, even if we try to resume the logical replication by just changing the synchronization information, it might not have all that wall or rows required. So, there can be a data loss. So, make sure if there are no data loss, we need to truncate and then recreate.
But can't we use the replication origin advance and set it to an LSN so that it resumes replication exactly from that point?
But it's possible that wall might not be there for on the standby node, because standby has no idea if somebody require that wall or not.
Yeah, in this case I am assuming that the standby has the wall, because I think even if it will try to connect, it will not be able to proceed if the wall is not there, right?
Yeah. If you are making sure that standby has the wall required by slot, then yes, you can advance LSN and resume it.
Yeah, and in case of synchronizing the standby slots from primary to standby, if there is a lag, that should not impact the consistency of the replication, right?
No. So that particular parameter synchronized slot we set on primary.
But it's not replicating or synchronizing in a synchronous manner, right? There might be lag between what's the status of the slot on the primary versus the standby.
Yes. So if we, let's say, standby has slot updated, some old LSN is there, but subscriber, like that slot information is asynchronously updated. So when we restart, subscriber will tell that, okay, give me information from this LSN, not this. Yeah, so there is no issue, like
so
we have all.
The confirmed flush LSN of the replication slot should not have an impact on the resuming the replication.
No impact.
Yeah, and in the subscription, can we use a VIP? Sorry for the extra.
Can we use
a VIP, a virtual IP, so that when the failover happens, we don't have to reconfigure the subscription with an alter subscription?
I'm not sure about that. Sorry.
Okay. Thank you.
Sure.
Why do the table sync slots need to be the table sync slots need to be synced if the table sync is already complete for that table sync work slot?
Okay, so when we start a subscription, so first table sync happens, but that doesn't mean that there can be some incremental changes which is done by table sync server before handing it over to apply worker. So to do those incremental changes, so yeah, that point is correct. We need table sync slot only if copy data is finished, but there can be some incremental changes which it still need to be applied.
So if a table sync is incomplete at the time of failover, do we what is the handling for that case?
So we don't keep those slots, and this subscription, when it will be resumed, it will see that that table state is not ready for incremental changes. It is still in copy status, so it will restart the copy.
Okay, so if you to summarize, if it's in copy data, the slot is not valid. If it's in copy data but not reached the apply worker phase, it would need a slot on the standby.
Yes.
Thank
Yes.
you.
We'll take a last question if you have.
Sorry, I have two questions actually.
Sure.
The first question is, do we still need to truncate the tables after the PG-17 sync slots? No, right?
No.
Oh, cool. Second question is like more about, so basically the idea here is if we have the replication slot synced on standby with the primary, then at the time where we promote the standby, we can directly use the information about where the slot was.
Yes.
And we can resume.
Yes.
So why can't we do the same thing with physical replication? What is stopping us from using the same LSN, restart LSN?
Yes, we can do. That's why I mentioned like it's still not done. We can do that.
Okay.
Yeah.
Alright, thank you everyone. We'll take a break and resume the other session.
Thank you.